don't know how many of you know who I'm. I'm Michael Whapples. I'm at Nottingham University doing a physics degree, and I have very little sight, basically just light and dark. And I've sort of had many different experiences with trying to get my notes into an accessible form. For this talk, what was I'm going to talk about? I'm going to be talking about maths and its accessibility and how the technology is impacting on it. And I'll mention things like Braille and how technology has improved the situation for that and getting documents in general. There's a few things I won't be covering in this, and that's things like what Braille is as such, to teach you Braille itself, because it's a very complex code and you'd be best to go on a course if you want to learn that in itself. But the other thing I need to just make clear as well is that I'm talking very much from my perspective as someone with very little sight. There's many different categories of visual impairment. Some people will use large print. Some people even will try and use tape recordings of lecture notes. But I use Braille by preference. But hopefully some of the ideas that I have used to solve these problems should be relevant if you try and consider solving those problems if they occur. The one thing also I'm intending to say with this is that a lot of the technology that I'm going to cover here, it will cost very little to implement it, because a lot of it's open source, because I use Linux a lot, and it's mainly just more the way you work rather than as such something really radical in different new technology and expensive equipment you need to buy. Okay, so I'll start with Braille, because that's been around for quite some time. Don't know how many of you know necessarily what Braille is. Do any of you? The other thing actually I was going to say is at the end I do intend to have a time you can ask questions, but if you want to ask any question that you feel would improve understanding the talk, then ask it. Well, basically, quickly, it is a system of raised dots to represent writing, and is used by blind people. And the 6 dots are laid out in 2 columns and 3 rows, a bit like this egg box with golf balls, and you can have different combinations. If the balls represent dots, you can see you can have many different combinations. Now, I wonder, do any of you know how many combinations that would be? The mathematicians should know this. And if you don't, I'm disappointed. Yes, 64. Yep. Someone that knows possibly binary then. So you can see that it is actually a low number, really, when you consider the number of characters are. If you were to look at computers, that for Unicode, which is a system of trying to get computers to have every symbol represented by a unique code on the computer, they defined 16-bit, and they're finding that even that, which is, I think it's thousands, possibly nearly millions of numbers. I'm sort of now showing that I failed to know what the 16 bits actually the number of combinations for that is, and they need to go to 32-bit, but it's a lot more than 64. So what can be done there is in Braille there's contractions, which can be combinations of having one character followed by another. So the first one will prefix the other, and then those two will actually mean something else. Or you may have combinations of letters, which may mean words like the for Braille. In Braille you would actually just write BRL. So you can make it more compact like that. Okay, so and you probably can tell that now that would hopefully work in normal text. But what happens when you get to maths? The one big difference is that Braille is a linear system, whereas if you have print, you'll know that you lay it out, fractions, one number actually over another number in 2 dimensions. And Braille doesn't do that, so you need to do it as if you were typing in a programming language. Don't know how many of you necessarily do programming, or any sort of computer simulation work where you have to do it by using the / on using lots of brackets. And there are some technical codes for Braille. Unfortunately though, these do vary between countries. It can even vary between countries with the same first language, like North America actually use a different maths code to we use in this country. Although some people in this country are using the North American standard because there's more textbooks and some argue it's better. But I'll come back to the North American system because of it's got a slightly different origin to most other Braille codes. Another problem with Braille is that sometimes there's not actually a direct translation available. Either sometimes it's such a rare symbol that it may not have even been defined, or in the case of fractions, you need to work out how you're constructing your fraction. So you can put it into this linear form, or sometimes the Braille actually will depend on the context. Okay, now moving on to some of the alternatives to Braille. And now I mentioned the North American code.
Desktop.
Oh, my laptop's just going to this. The North American code, it is different because it was actually designed originally with maths in mind, whereas most of the other codes have just evolved over time and extra characters have been added as and when needed. Now the one advantage with the North American code is that it does stick to the 6 dots. You'll see that there's actually a new system which doesn't stick to 6 dots, which I'll mention later. And because the North American code has been designed specifically for maths, well, it's meant to be better like that. Now I mentioned that there's some Braille system which has broken from the idea of 6 dots. It's called Dots Plus, and what that does is it will any complex symbols it represents by a graphical raised symbol, and it's fairly well just a font substitution on your computer, and it's meant to overcome a lot of these problems with is there a direct translation, do you need to restructure things to make it actually read properly in Braille. It does have the problem that it does break from the 6 dots, and I will come back to that later on when I actually mention the technology you use. Actually, I could mention it now because typically Braille used to be written with either there's a typewriter that has 6 keys to punch out each dot, or even older technology is this, which is a Braille frame, and you'd have a sheet of paper in there and then you have a pin to poke out each individual dot. So this technology you are restricted to the 6 dots. So you couldn't actually write Dots Plus with that or the typewriter. But if you have a look at this, and I will get it handed round, you should be able to pick out on this second page where there's a fraction, and hopefully you'll understand roughly at least where the equations are. So you could hand that round. Whereas this is actually Braille. Unfortunately, it's not actually a copy of that dots plus I've handed round, but on the front page there is a fraction in there, and if any of you can pick it out, I'll be quite sort of amazed, unless there's any braille readers amongst you. Okay. So what other alternatives are there? There's speech access technology. Now this has the one big advantage that it uses fairly cheap technology. You can use a tape recorder to record notes onto. It also doesn't have its own special codes. If you do maths, you would know how to speak out the maths itself, hopefully. So it should be fairly easy to get it done. The drawback I find with it is that if you have large equations, it can be difficult to follow, or sometimes how do you make things clear? Like if you have a fraction multiplied by something, say if you had x over y plus 2, where's that plus 2? Is it in the denominator, or is it in actually just added on after the fraction? So although I have heard there is a specific set of rules that has been designed. Okay, now moving on to technology itself. I understand that a lot of you here actually are approaching it from the accessibility side, so you should know about screen readers, enable you to surf the internet, find out plenty of information, communicate by email, loads of stuff, scan in books, so you can now read books, and it's had quite an impact. And there's even sometimes more advanced things like programming, or possibly not actually computers themselves, but technology itself has enabled I can actually do air rifle shooting, and I was not sure if I was going to be able to come to the talk before, because the radio station was interviewing me on that. So you can see that technology has made a very big difference. Now, what technology enables all this to be done? The screen readers, and I can
desktop frame.
Demonstrate this with my laptop here. That
top panel frame, top panel, panel notification area, embedded component, menu bar, applications menu.
You can hear
accessibility menu.
It reads out the menu options and what's on the screen.
Desktop frame, icon, new layer of pane.
And it can read documents, and it basically gives you speech access to what's actually on the screen. There's also braille displays, which is this device here, which has a set of pins which are operated by piezoelectric, which raise up and down and will just represent the braille itself. There's 40 characters on this particular display that it can show, and on the projector you can actually see at the top, I think, there's a bar which actually shows what will be on this. And you may have noticed just when I was showing that screen reader that it was changing to show what as such was selected, and that's what was coming up on this braille display. There's also braille embossers, which is basically a braille printer for a computer, and that was one of the issues that with the Dots Plus system, a lot of embossers could only do the 6 dots. So in that case, Dots Plus couldn't be produced, and it was one of the problems with when it was being designed, Dots Plus. How were they going to output this system? And eventually they managed to make an embosser which could produce graphics and those graphical symbols. And initially, unfortunately, it was very expensive. But I think it's come down a bit in price now. Also, there's braille translation software. Now, unless you know about braille itself, you possibly don't know why necessarily a Braille embosser or a Braille display would need Braille translation software. It's, as I said before, when I was talking about Braille, there are contractions, and Braille translation software is meant to know what all the different codes, and you tell it what code to put it into, and it will use whatever appropriate contractions to get the Braille display or the embosser to show the right Braille. Okay, so then there's now, how does this technology impact on the maths itself? So you can read and write maths documents. This can be done in many different ways. There's Wind Triangle, which is on the list of useful links, which I'll hand out, and also there's a PDF document which I'll put on my website and possibly will be on the website with this video. And Wind Triangle is a graphical based program for Windows which will enable people to create documents with maths in and itself voices, and I think they're working on adding Braille support for it. Or if you like me, you actually produce work in LaTeX, which just uses any text editor, and most Access software can read a text editor. What other technology is there that's relevant to maths and science? As I mentioned, science, and I'm doing physics. Well, there's many different devices. There's things like talking calculators, talking voltmeters, which I've got here, a talking voltmeter. Actually, this one, it can do things like resistance as well. So if I just get it to
DC 4.7 millivolts.
Oh, I'm producing the voltage. Which is a bit, I thought it was actually set to resistance, but so you can see that, and you have talking calculators, which are boxes like that, which are calculators, and will voice what's being input and the result, and you can get it to speak what's done. Or the other thing with calculators is that there's actually the same company group that did Wind Triangle. They actually came up with a graphing calculator, which is a piece of software for the computer which produces the graph by making a varying pitch of sound. So the pitch rises as the graph rises, and it just scans across the graph. There's other math software, like possibly you know that in maths you may have things like Maple to do numerical integration, and or MATLAB as a programming language to do mathematical operations. The accessibility on these can vary. There's some which do work. Maple supposedly does. There's MATLAB works to an extent. I've used it before in Windows and it does work, but as I said, to an extent. The help system was not particularly accessible. Sometimes you need to know also how to turn the accessibility features on, because they're not always on by default. But there's sometimes some software which is just not usable, and typically these used to be Java-based programs. I'm not sure in Windows what's necessarily happened there, because I know that at one point it wasn't very good at all. Maybe Alan, using Windows and being more up to date with it, as I've moved to Linux now, he might be able to say.
JavaScript is difficult one. Sometimes it will read depending on what
Yes.
being done.
So it's variable in what it will actually sometimes read.
Yeah.
Now, I'm just trying to check what I've actually. Yes, as I said, it depends on what's really used. It's still early days, and there's some promising projects to try and make various things accessible, either in their own way by making their own implementation, like Wind Triangle, or some companies like MATLAB, the ones that produce MATLAB, they actually, I think, are trying to incorporate some accessibility into their software. Now, why are some things inaccessible? One thing would be equation editor, and I remember having a bit of a discussion with one of the screen reader companies for Windows when they were improving support for Word, and they were supposedly going to get perfect access, and I sort of said to them, are you going to support equation editor then? And sort of hopefully, but then they sort of said, unfortunately there's not enough people wanting that feature. It's not worth our time, we're not going to. Which I find a bit disappointing. Sometimes it's because of the way the actual things are done. Like if you have maths on a web page, sometimes if you use LaTeX, you compile it to HTML and it just inserts loads of images for the equations and may not even provide any alternative text. And if you were here for the previous talk about PowerPoint and accessibility, you'll know about the alt tags, or if you look at the W3C website, you'll see about the importance of alt tags. But that situation could be improved if you use something like MathML, which can be read by various products as Math Player in Windows, and if you're using other platforms, there's Firefox, which has a plugin called Firefox with a V in there, which can speak MathML, and that's promising. As I said, that's only giving speech output, but I know the developer of Math Player, he is actually trying to get some vowel translation as well added in. Also, what about the difference in if you're using something like Linux, as I know some mathematicians and scientists use Linux. I now mainly use Linux, and as you saw, it on my laptop at the moment it is running Linux, and you saw that it does read menus, it does read some stuff. Anything that's in the text console will normally be actually accessible as well, because there's a screen reader which patches into the kernel itself and will read anything that's printed to the screen, basically.
Yes.
Okay, now I'll move to Braille translation, as this has been a big part of my problems with getting lecture notes, as I'm a Braille user mainly. It mainly comes from the problem that Braille translation software at the moment, which exists, does the job fairly poorly. Possibly a bit of an understatement, I think, but it's definitely not really up to university standard at all. And it's also a bit unreasonable to expect a university to have someone who can read Braille maths. Well, it's unlikely you'll find that they can read Braille at all. It's one debate I've got with my university, that should they have some sort of check on the Braille notes that have been produced, because they've had it come back in the wrong code, and just simple mistakes which really just shouldn't happen, and with a quick proofreading would be highlighted within a matter of minutes nearly. In fact, I sort of thought the situation was so poor with the translation software itself, I actually started writing my own Braille translation software, which wasn't a small task, and I had to make a few attempts at it. I sort of started, thought, no, this is too much, backed away, and eventually last year I did actually get going with it, and I've got something which is working reasonably, and I've made it open source, so others can add to it if they want to. Now, as I'm saying that I did this and have been critical of others. What was I seeking from a Braille translator? Well, as I said, it's rare that you'll get someone that can actually read Braille maths. So it would be useful to have something that's definitely reliable, that can be just relied on. And I've actually had other thoughts since I started writing my Braille translation software, that possibly should it even have it that it does the translation into such a form that then someone could proofread it without actually knowing Braille itself, so that from that stage to where they're proofreading it, the translation rule is so simple that nothing should go wrong. What else was I seeking from it? Well, at the moment the main one that gets mentioned for maths and Braille is a commercial product, and well, if you find a problem with it, you've got to basically just let the developers know, and you're just waiting for them then to implement it. So I made it open source so that if anyone finds a problem, they can hopefully just try and correct it themselves, and even contribute back to it and make it better. Also, I feel that it should be that people can have Braille in whatever code they want. If they want it in the North American standard, then they should be able to get it. So eventually I want to make it that my Braille translator can cope with multiple codes. Okay, I'm just thinking, just checking the time.
23.
Yes, so I think I'll now just come round towards the summary, as I am getting towards that bit anyway. So, what have I basically mentioned, just to quickly, briefly say this. So generally, the accessibility to technology is very good and has made a huge difference. As I said, scanners now mean that you can read just a book. Yes, it's not always accurate, but you can normally get the gist of it. And communication by email, now you're not having to try and get letters read and stuff. And you can shop online. And so it's made a big impact. There's for the maths itself, well, this isn't quite up to the same standard, but hopefully through things like MathML, if people try and actually implement that when they write notes, if they write it in LaTeX, see that, say, one of the LaTeX converters will actually convert it into MathML, because I had one set of notes that didn't translate. It just refused with any of the converters. There was only one LaTeX package which would compile it into anything, and that was PDF, which I've realised I've not mentioned. And also the same goes with the software, that if you choose it correctly, and say if you're looking at possibly purchasing any new like maths software like Maple, just check what accessibility features are actually there. And I'm not sure with this country's law itself, but I know in the States that it's been announced that in Texas they actually now won't buy the government there won't actually buy one particular company's software because of it being inaccessible and all the equal rights that they have to do. So you should possibly just consider that when buying it. Now the one problem that there is that there's not many people coming. It's difficult to do, as I've said, sometimes getting notes. If people compile it into HTML and that HTML only contains images of equations, you just got no idea of that as an equation. And unfortunately also in the case of like the equation editable word, developers are just not interested when there's only a low demand and people are being put off by these difficulties. So something has to change, as in a developer's got to be brave and say these people may come forward if we put the effort in now. or you've got to try and possibly encourage people to come along by possibly working in a good way by, say, having MathML, as I said, or accessible software. And I think I've fairly well come to the end of that bit. Does anyone have any questions? There was actually one bit that, if there is time, I was going to possibly mention diagrams, if there's any interest as well.
Just PDFs, really, what you were saying.
Yes, okay. The PDF bit that I was going to mention. Now, there is tagged PDF, which will give information to a screen reader about how it's meant to be read, in what order. It's got very much a similar concept to MathML, that it will have a logical structure to give it all the information, and I think it even will extend to maths. But no one has actually implemented tagged PDF for maths at the moment. So if, say, there's any interested people for any interesting research, possibly tagged maths PDF would be a good accessible one. But unfortunately it's also the software to write PDF doesn't write tagged math at the moment. So PDF can be a problem, but from just normal text it's fairly reasonable in some cases. Just make sure also it's not done as an image like HTML sometimes. Some people scan it in and then just put it into PDF, not putting it into text.
That's what Alan's program does. What's it called again?
Text talk.
You keep telling me, one day I'm going to remember.
Yeah.
The text talk will read it. Yeah.
Well, Adobe Reader actually, I can actually quickly show you, say, with my
Desktop
laptop.
frame.
I just want to think where I've put. Yes, no.
Top and sound. Program office menu.
I'm just trying to think if it's actually on this. No, it isn't.
Adobe Reader. Desktop.
I'll just see if it is actually. But Adobe Reader does have accessibility features built in.
Oh, I know, yeah, but I mean, I'm just saying
Adobe Reader
that program Alan was mentioning will read PDFs that are not accessible.
Yeah.
Oh, okay. Also, actually,
Which
we're
is
going to mention
very
that.
handy, and it reads other formats.
I
as
think
well.
some optical character recognition software will do that as well, but it won't necessarily pick up the structure corrective of, say, columns or something. That can be a problem.
Yeah, well, but, people should use the accessibility tools really, but I mean,
Yes.
they don't.
No, I mean, it's good practice if people put it in, and I feel sometimes it's very much, if you start out, if say you're starting out with a new set of notes now, try and make it in the accessible formats, as it's not really going to be a huge amount of work extra, I don't think,
Not if you
when you're
start
starting
that
from
way,
scratch.
yeah.
And that's what I meant, if you're starting with a set of notes now, if say you're starting a new module and there's no notes at all for it, make sure it can pass with, say, text for HT if you're using LaTeX or something, which will then put it into MathML, rather than having LaTeX which is compiled to PDF.
Yeah. What we need, like this Sudoku thing, we need something like that, more mathematical for older people who have a range of disabilities, and because there's more and more and more of them, that just increases numbers, encourages the developers to do it for everybody.
I've had the same answer as Michael, that you talk to companies and they say, oh yeah, we're interested. Well, there's not enough.
There's not enough, but we're growing with old people.
That's the one thing that actually is happening, that as the people are now living longer, more and more are starting to get visual impairments because the eye can't last as long as the actual, it's not adapted like people have to live longer.
Yes.
Sometimes companies haven't even heard of it though. I emailed a company and said, is your software accessible? What do you mean by accessible?
I know, yes.
And I went on to explain, she said, we have no idea, but she said to me, but if you find out, do tell me.
No, but then we do.
Well, at least it was
but
slightly
it's true,
positive
but we
that-
do have companies now, quite a lot of companies that our students are going on placement where they are doing accessible web development.
Yeah.
It's becoming more and more of it. And I think it certainly will be the case as we get more and more older people who are, have a very big range, motor, visual, all kinds of disabilities, and as they become more of a force, which they are becoming. I mean, it's a shame that it has to wait for that, but it is, it will help.
Well, as I said, it's also possibly that possibly at universities you need to try and maybe make stuff as accessible as it can be now, to encourage slightly more people to say start on these courses too, and then the demand is there for the commercial companies to want to do it.
Yeah, well, I agree, but you do have to just keep on and on and on.
And I'm just thinking that's the one bit with Linux, that because it is open source, normally if there's a want, someone
will do it.
May do it. It's not got to be profitable.
Yeah.
They just, if they want it, they'll do it. Possibly.
I know there are some interesting.
Well, like me, that I just sort of started that because I felt I needed it, so I made it available to everyone else as well. Because, well, what's the point of just keeping it to myself?
Yes.
Just out of curiosity, did you give that a name?
Yes, I did. And it's actually on my list of... Oh, you've handed it out. Yes, it's the first one, BRL Tex.
Oh, yeah.
That's my Braille translation software. I think I did actually say it was mine on there, but I can't remember as I quickly put that together. I'm just trying to think, actually, that might be useful for me to quickly go through what's actually on that sheet, and I'm just trying to remember, there's my Braille translation software first. What's the next one, roughly?
NFB
yes, that's sort of mailing lists, which may be useful if you're interested in, say, if you do get a blind student on a course, sort of go to that and email, and someone hopefully will have an answer for a question, or it may spark off an interesting discussion if not anything else.
Science Access Project.
Yes, the Science Access Project. They developed DOTS Plus, and they then developed this embosser the Tiger printer to do that. So that's interesting, as they've actually got some technical information about Braille and the dimensions it's meant to be, which, to be honest, for most people will be irrelevant. But it's just, there's some interesting stuff on there and useful links. Then I think there's one which is an article. Yes, that one, as I said on that sheet, is not maths specific, but you probably will find there's interesting comments on it, which may be relevant to a learning environment. Like they mention e-books, that with all this added security features, there's sometimes the security features will prevent any accessibility technology accessing it because of the risk of copying, which is a bit of a problem. Or with the rights, audio rights for getting the software to read it out. The e-book readers sometimes have speech software built in, that's disabled because of it, that the rights are sold separately. So it's got some interesting bits. As I said, not necessarily maths, so, but you may find it useful to sort of like use it.
Firefox, isn't it?
Yes, Firefox was that plugin for Firefox, which will make it speak and does MathML, and is about the only option for Linux and other platforms. Math Player is a plugin for IE, Internet Explorer, which does speak maths, and it does have actually other accessibility features, like I think you can zoom in on equations and stuff. So that's why I'm saying MathML is a good way to be going, because they are trying to make it work quite well with Math Player. Wind Triangle. As I said, this text editor, not text editor, editor for maths, which is self-voicing, and they're working on Braille output, and it's a bit easier to learn than necessarily learning LaTeX, and say someone at school would be better learning that rather than LaTeX.
W3C map page.
Yes, that's just a W3C which lay down the actual MathML, and they've designed it, and it's basically very technical, what you'll probably find there, but it does have links to converters and software that can use MathML.
And TTM.
TTM, I had to just include that because it's one of the MathML, latex to MathML converters for, well, they are Linux and Windows versions, and it works fairly well. There was one converter I wanted to put down, but I couldn't find the website for it, which is also text for HT, which most LaTeX distributions will actually include, like Scientific Notebook will export to LaTeX, and then I think it has an option to use text for HT to get to MathML. And I think that's...
Yeah, great.
So is there actually any questions, possibly, or...?
I was just going to ask, is there any technology you see on the horizon that's going to be that's a big thing that you're kind of waiting for? Anything that?
I think at the moment the biggest thing I'm really waiting for would be, say, for some of these newer standards like MathML, tagged PDF, really to take off. I'm not sure necessarily that it would be a physical device like, say, a Braille display or something, that, because although what would be nice would be, say, a Braille display which isn't limited to the Braille cell, which, say, could display a graphic, so you don't actually have to print out graphics onto paper and then find that graphic wasn't useful. You just wasted paper. So
there's more an acceptance of existing standards and
yes, I think that's
widespread.
And also then for the software to develop to become more advanced and say can produce Braille output, as at the moment it's mainly speech output that you can get from MathML.